In this module, you will learn about inertia. The essence of the first law of motion is that all objects resist a change in their state of rest or of uniform motion. For example, when you try pushing a boulder at rest, it resists motion initially. However, if you exert enough force, the boulder starts rolling. Consider another situation where a truck is carrying an unfastened load. When brakes are applied suddenly, the truck stops, but the load moves forward and hits the back of the cabin. This is because the load tries to retain its state of motion. This tendency of undisturbed objects to stay at rest or to keep moving at a constant velocity is called inertia. You can see this concept when you play a game of carrom. If a fast-moving striker hits a vertical stack of coins, sometimes only the bottommost coin in the stack is pushed out. The rest of the coins in the stack remain intact. The stack of the remaining coins comes down vertically, retaining their position of rest. This is because no force was applied directly on them. Now let's look at an object that retains its state of motion. A satellite orbiting the Earth continues to revolve with constant velocity, as no external force, such as friction, is applied on it. In real life, on Earth, it is difficult to find an ideal frictionless surface. Let's analyze some more cases where we observe this law at work in our everyday life. Look at the standing passenger in this bus. The bus starts suddenly, and the passenger is pushed back. This happens because the lower part of the passenger's body, which is in contact with the bus, begins to move with the bus. However, the upper part of the body tends to maintain its state of rest. As a result, the upper body tends to fall backwards, and the passenger experiences a jerk. Similarly, when the bus slows down by applying a sudden brake, a standing passenger tends to fall forward. This is because at this time, the lower part of the body, which is in contact with the bus, tends to stop while the upper part of the body resists the change and tries to maintain its state of motion. Now that we know what inertia is, the next question is inertia equal for all objects? There isn't a yes or no answer to this question. Inertia is proportional to the mass of an object. This is evident when you try to push empty boxes versus boxes filled with packages. It is easier for you to push an empty box. Kicking a football around is fun, but would you try kicking large stones of the same size? No, that would hurt, as you can see. So, remember, the larger the mass of an object, the greater is the inertia. Based on this, if you compare a car and a train, and a plastic coin and a nickel coin, which of these will have more inertia? You would need to compare the mass of each set of objects. The mass of a train is more than the car, so the train will have more inertia. Similarly, the mass of a nickel coin is more than that of a plastic coin. Hence, the nickel coin will have more inertia. We are all advised to wear seat belts while driving. Why do you think that is so important? Let's find out. When the driver of a car applies brakes and the car slows down or comes to a halt, have you noticed that the driver's body tends to continue in the same motion due to inertia? Inertia is the reason the driver is pushed forward in such situations. The seatbelt restrains the body and prevents this forward motion. By doing so, it protects the driver from injuries that may result on sudden braking at high speeds. In absence of seatbelts, applying sudden brakes may cause the driver to hit the steering wheel or front panels of the car violently, resulting in an injury. As the first law of motion explains the concept of inertia, it is also known as the law of inertia.